This is Lab 1 for Mechatronics by Emma Brooks. So when we measure the components of our circuit, we see that instead of 5 volts, we actually measure 5.06 volts. And for R1, instead of it being 220 ohms, we get 218 ohms. R2 and R3 are measured on the next slide. For R2 and R3, we see that instead of 1 kilo ohms, we get 1004 ohms for R2. And then for R3, instead of 220 ohms, we get 219. Here we've redrawn the circuit using our actually measured values so we can calculate our theoretical values. Using a KVL and rewriting each voltage as I times R for that specific voltage, we get a matrix. And by multiplying the inverse of matrix A by matrix B, we get the following currents and voltages. So for I1, we should measure 12.7 milliamps, I2 should measure 2.3 milliamps, I3 should measure 10.4 milliamps, and for the voltage across each resistor, V1 should be 2.77 volts, V2 should be 2.31 volts, and V3 should be 2.28 volts. We've measured each component and calculated our theoretical values, we can actually start building our circuit. So first, I'm going to place R1 and connect it to the voltage source and then bring it to the middle. And now I'm going to connect R2 in series with R1 by placing one branch in the same row as R1. After extending R2 down the column, I'm going to connect R3 along the same row, connecting to the ground on the other side of our circuit board. Now I'm going to use a jumper to connect R2 to the ground as well, so R2 and R3 are both parallel with each other and in series with R1. Once I turn my circuit on, I can then measure the voltage for each resistor. So for R1, I see that I get a voltage of negative 2.76. The negative sign is just because I have my probes on the wrong sides. For V2, I get a measurement of 2.27 volts across R2. And then for R3, I get a measurement of 2.28 volts. Again, the negative sign is just because of the placement of the probes. So in order to measure the current, what I need to do is break the circuit and stick my multimeter in series where I want to measure. So right here, I break the circuit so I can measure I1. And so for I1, I read 12.2 milliamps. Here I break the circuit again to measure I2, and for I2 I get a reading of 2.1 milliamps. And for I3, I break the circuit once more and I get a reading of 10.2 milliamps. I've measured the actual voltage and current, I can then compare them to my theoretical values. As we can see, my theoretical values and my actual values are very similar to each other.